we'll go for the round of questions after Alfredo's and Miguel's talk, please.
Okay, so thank you also for inviting me. So my name is Alfredo Escalante, and for 7 years now, I'm at ESA, here in the European Space Astronomy Center near Madrid. So I'm in a contracting company. We are called Starion. We lead the SPICE service. And maybe my PhD path has been a bit unorthodox, let's say. But I think it really bridges a lot the gap between industry and research, especially in the space domain. So I will give you just, I will try to be brief. I think it's better if we do maybe questions after if possible. So to give you a bit of background, so I did the bachelor and the master in aerospace here at the university. During that time, I also did a few internships and work in Huawei, in Airbus, and in Altran. And then in 2019, I did my traineeship in ESA. So there I started working with missions such as Rosetta Huygens and even Apollo 15. Basically in remote sensing, so something that we haven't really do in the masters, but of course the skills that we learn, astrodynamics, even electric propulsion, was very useful for working these missions. Then after the traineeship, I was freelancer for 1 year doing stuff on VR for ESA projects and for other stuff. And then after that, I was contracted by REA, which is the same as Starion, just we rebranded, as a SPICE service engineer. And I will tell you in a bit what SPICE is, but just part of the science operations in ESA. And then in 2021 was a busy year because I started a PhD with the supervision of Professor Manuel Sanjurjo in optical navigation in space missions with deep learning. So it's a bit of a weird mix. Something that it's very useful in space missions, but normally it's done in either Netherlands or Germany, nothing to do with what we do at ESA, but still very much related. So it was very useful to bring some of that to the table. And then on the same year, I took over the manager position of the SPICE service until today. And just last month, I finished the PhD. So I will try to tell you a bit how it relates with the work we do at ESA. So in ESA, we have a couple of very important stuff for ESA. One thing is the Science Archive. So all the science that is produced by all the ESA missions, it's archived in ESA. But to me, the most important part of what we do at ESA is the science operations. So in the end, we pay hundreds of millions of euros to send a spacecraft to Jupiter, and the main product that we have are the images, or the spectrometer, or magnetometer, whatever. So we need to plan very carefully those measurements. So as you can imagine, this involves a lot of astrodynamics, knowing instrument modeling, spacecraft modeling, propulsion, lots of things. And what we do at ESA is just plan this, what we call the timeline. No? So it's basically what we need to produce is at which time we point an instrument to some place on the surface of a planet, for example. And in terms of interfaces, it's probably quite one of the most interesting parts of the chain in the operations of a science mission, because we interface with all the instrument teams of the mission. For example, JUICE or BEPI, they have like 14 instruments. Each of them have an instrument team across Europe or even in Japan or US. So we interface with all of them. We take also all the science goals of the mission, so all the requirements, and then we interface also with the Mission Operations Center in Germany, which is basically the people driving the spacecraft. And then we make sure that the measurements that the spacecraft is going to take, it's fulfilling the science goal, and then everything it's uplinked to the satellite. So especially on that, the SPICE service, which is the team I'm leading, we focus on providing geometric calculations. So as from the description I gave, probably you can imagine that all this is very much related with geometry. So we need to know, it's important, a lot of knowledge in terms of algebra, trajectories, propagation, pointing of instruments, instrument modeling, systems in the spacecraft. We need to fulfill all the requirements in terms of power, data rate, all sorts of things. So for all that, we use SPICE, which is integrated in all the core tools that we have in ESA for the science planning, for processing data, for archiving, so in all sorts of stuff. So save models, for example. which is also very much related with the PhD. So this is what I have been doing in ESA for 7 years now. And then to tell you the other part, which is the PhD, so we were focusing on applying neural networks for optical navigation, which in a very simplified way, this is just from a single input image, get the position and the attitude of the spacecraft. So this is something critical for missions such as Rosetta, that went to Comet 67P, or Hera, that will be arriving at the Didymos system later this year. Right now it's done by very complex algorithms that some of them even require manual intervention, and it's just not feasible for low resources missions. So with this, we would bridge that gap, and we would allow, for example, CubeSats to be sent directly to the moon or to asteroids, like to Apophis soon in 2029 that will fly over to the Earth. So there are very important or several points related to the PhD. So this is mostly related with GNC, Guidance, Navigation and Control, which is something that it's not for sure done at ESA, which is science. So it's most of the people that are scientists rather than engineers. So this is normally done in Germany or by some companies like GMB. But this has a strong component here on the navigation part. But then it has a lot of instrument simulation and planetary data, because the only way we had to train the neural networks is to simulate ourselves the data. So for that, we have to go through all the data of different celestial bodies of past missions. So that is more related with what we do at ESA. So that was a great asset to be on site, collaborating with the planetary scientists of BEPI, Mars Express, TGO, even Rosetta. The people that actually was in charge of the optical navigation in Rosetta mission was there, and they helped a lot with ideas and actual knowledge of how it worked. But then it also have a lot of maybe on the computer science part, so on 3D rendering, machine learning, and also on the part of hardware validation, because in the end we couldn't, but we were going to upload to an Earth observation satellite to test the whole methodology. So as you can see, both PhD and what I do at ESA, it's space-related, but it's substantially different. On ESA, it's most related on the science part and science operations, and this is more on the technology part. But of course, both are strongly related. So for enabling the science, we need the technology. So for example, what I did in the PhD, we will test it live on Hera mission, for example. But then also for the technology, we need the science goal, right? So maybe we are developing a very nice and fancy technology, but we need, of course, a real need to actually develop the technology. So that's why I think that being in industry, in this case in ESA, but also doing a PhD brings a lot of things to the table on both sides. Because for industry to the PhD, you get a clear idea of what is needed and where to go. And also on the other side, you have a lot of skills that you learn doing the PhD that just people in industry normally lack. So now I'm not trying to steal anyone from the PhD program, but to give you an idea of opportunities that we have at ESA, and most of them are either to do a PhD or compatible to do a PhD as I did, which I did not mention, but it was as a hobby. But because it was very much related, it was easy to compaginate both. So this is a complex diagram that they love, I don't know why. So on the left side, it's on master level, so you can access a trainee program, which is what I did. And this is probably will give you a good taste of what is needed in the current ESA programs. And then it's also a good step to go there and then do a PhD on a similar topic, which is exactly what I did. But then on the bottom right, there's the opportunities related to PhD. So ESA offers the opportunity for you to submit a proposal on a PhD topic, and also together with a university, and they will fund half of the project. So half ESA, half the university. So if you have interesting projects that could be related with some of the ESA programs, you can do that. And also, in case someone that already has a PhD here, they also have the Research Fellow program, which is most for postdocs. Normally, they are more focused on astronomy or planetary science, but still, some of them are on the technology part and even at ESA. So for example, even for electric propulsion, if you could be at ESA, you would be able to have hands-on the data from the electric thruster on Bepi Colombo, which was derived from a Smart One. So it's the whole inheritance on space propulsion for deep space exploration. So even you were doing something different, you still have access to the data and have a lot of possibilities doing that. So that's on the ESA side. But then actually most of the people working in ESA, they are not ESA staff, they are contractors like myself. And actually currently at ESA we have these 3 vacancies, especially probably for the aerospace engineer profile. The first one is the most interesting one. So it would be focused on developing the software that we have been using for 20 years on mission planning and on spice also. So it would be a very similar case as me. So it would be quite easy to find a way to apply what you do there to a PhD and actually bring something innovative to basically that software that was used already in Venus Express. And I think that's pretty much everything I wanted to say. I think it's better probably we discuss later or have questions.